My name is Kainton Newton. Today we are going to actually be playing with data. In the previous lesson, I showed you how to get free data sets using R and also how to export this data and use this data in another application. So today, let's see how we can actually play with data, more like getting around this data we have. So let's quickly display a particular data that we have inside R. So that data should be inside a package called ISLR, which we already have installed in the previous lesson. So we have this data set called auto. So I'm just going to say fix auto so that we see this data set. Remember to subscribe if you've not subscribed to my channel, so you can see that we have the data set here made up of several columns and different rows. Now to view the number of rows and columns, you simply say dimension auto. So at this point you can see it has 397 rows and 9 columns. Now assuming we have missing values, so missing values is a problem in data analysis. How do we handle missing values? And that is where na.omit comes in, because sometimes you want to do an analysis and there is some values that are missing. Then the analysis you may have problems completing this analysis. So what you can simply say is you run na.omit. So that is going to actually remove all the records that contain missing values. So let's see. So what we can do is auto is equal to na.omit auto. So the output of na.omit, we are reassigning it to auto. So at this point, if you do this, it will remove all the missing values, rows containing missing values. So I don't know if actually there's any missing value in this record. Let's see. So actually there is no missing values, but this actually is used to remove missing values. Now you want to know the names of the columns in this data set. You simply say names auto. So that is going to give us all the column names. Now you can see the 9 column names are displayed: mpg, cylinders, displacement, horsepower, weight, acceleration, year, and the remaining 2. Alright, now if we want to refer to only one of these columns, we can actually say something like auto, and we use a $sign and then refer to either of the columns. So when you press the $sign, it now refers to the columns, and now you can display just one of those columns. So we have 397 rows under mpg, right? All right, so what next? We are talking about names. There is something I forgot to write, and that is summary. You can actually view summary of your data sets, and to do that you use the summary command. So let's try to use it. It's going to give us a summary of the statistics on all the data in this data set. So when we use a summary, it gives us, for instance, if we have an mpg column, the minimum value there is 9, the maximum is 46, the mean, the median, the first quartile, and the 10th quartile. So this is basically the summary of the auto data set. Now, if we want to refer to the columns without having to use the $sign, remember we mentioned that you can refer to particular columns by using a $sign. But if you actually want to refer to these columns without using a $sign, maybe you want to just simply say something like mpg, and it displays the mpg column, you can just say attach auto. So what this is going to do is going to expose the columns. I run this command before, so it's going to expose the columns of this data set so that you can actually refer to these columns without using a $sign. So at this point, if I say mpg, I'll actually have the data set or the column for mpg. All right, so let's now look at the next one. qualitative and quantitative variables. Now this is very important. Now what I'm going to do is to first display the data set so that I'll explain to you what we mean by qualitative and quantitative data set, or qualitative and quantitative data. Now if you are doing data science, then you should know about quantitative and qualitative data. Quantitative data are simply data that can be referred to as continuous variables. Let's take for instance the acceleration column here that's made up of 12, 11.5, 10.5. So it's continuous, it's infinite. It can be 11.25, 11.235, 11.7. So this is continuous variable and it's known as quantitative data. And we also have other ones. In fact, all of them are considered to be quantitative data. But if there is some that we have only few options, for instance, in this year column, we have only 7. So let me take out this. You only have 70, 71, maybe 70, 71, and 72. Or in these cylinders, you have 4, 6, and 8. Cars can only have 4, 6, 8 cylinders. So it means that you can consider them to be qualitative. That is only 3 classes. Consider them as 3 different classes instead of numbers. So we can have small, medium, and big. So we can say 4 represents small, 6 medium, 8 big. So in that way, we convert it into qualitative. So qualitative is more like discrete, while quantitative is continuous. So to use the cylinders as, let's display names again. Names. So to use cylinders as qualitative data, because the default is quantitative, what we can do is simply say, I can't remember exactly, but let's see, auto.as, or can say as.factor. Okay, so as.factor cylinders. Okay, so let's see if it works. So that means that the cylinder column will now be considered discrete variables, right? So maybe when we actually solve real problems, we be able to understand it more. So you now have only how many levels? 1, 3, 4, 5, 6, 8. So this is more like about how many classes? 5 different classes. So it's considered as classes this time instead of qualitative or continuous variables. Let's quickly do a histogram of one of the columns. So let's say hist. Let me do a histogram of the MPG and let's see what we have. At this point, I'm going to extend this and I'm going to shift this and let's say margin too large. Let's try to plot a different thing. Hist cylinders. Error in default X, so X must be numeric. So cylinders now is qualitative and can be plotted. Let's try something else. Let's say hist. Hist displacements. Okay, so we have a histogram of displacement, as you can see. So let's play around. Let's try to color it maybe blue, right? To color it, you simply say col equals red. Okay, so if you want to color it red, and so on and so forth. So you can actually change the color to what you want. Let's see what we are missing out. So we have pairs. So to do a pairwise plot. So pairwise plot simply means you plot MPG against cylinder, you plot cylinder against displacement, you plot horsepower against weight, and so on. You plot one column against the other column continuously for all of them. So you simply say pairs altered. So this is necessary sometimes to help you gain insight on how this data actually looks like. So this is a pair plot. So let me see if I can zoom. Okay, yeah. So this is a pair plot of all the data we have in our data set. So you have MPG versus cylinder is this. Cylinder versus displacement is this. So you can always find the particular graph using the diagonal which displays all the column names that that is in the data set. So this is what a pair plot is, or a pairwise plot is in machine learning or in data science. So I think by now I'd like you to take some time to go through all of this, try to understand them. We are playing around with data. There are many other things we can do, but I want to keep it simple and clear and also interesting. So try to play around with this data, try to change up things and make sure you understand exactly what is happening. Remember to subscribe if you've not subscribed, and also like this video, share with your friends, and let me know in the comment below if there's something you'd like me to do more.